All right, everybody. Today we've got another interview. Today I'll be covering tech positions, engineering, and things of that nature in particular. I've got my good buddy Reg Brookins with me. We're doing an in-person today, none of the over Zoom stuff. And with that, I'll go ahead and let you take it away. Introduce yourself.
Okay. My name is Reg Brookins. I was most recently the Senior Systems Administrator for PSC, Puget Sound Energy, and also the Senior Systems Engineer for L3 Communication Systems here in SOC.
Nice. So I know, we've been friends long enough to where I've got a pretty good idea of, sort of the path you took, but for their sake, what got you into tech? How did you start off as an engineer?
I think when I was a kid coming up, you were doctor, lawyer, engineer. It was kind of the track a lot of people took. I was always pretty good at math, so for me, engineering was kind of a natural fit. My brother was a chemist, and he kind of pushed engineering, and I was really interested in building electrical systems.
Nice. So any advice you have for anyone in today's market, post-digital explosion, that wants to get into tech from nothing?
Yeah, that's a really, really, really good question, actually. I think for a lot of programming positions, especially entry-level programming positions, a college degree is no longer necessary. It's good to have, don't get me wrong. Having a bachelor's degree in computer science or having a bachelor's degree in computer engineering is definitely a big plus. But even a BS IT, a BS in information technology is also a big plus. But there are so many different boot camps nowadays. There's so many different self-help and self-teaching manuals, right? JavaScript, Java, Python, Ruby on Rails. Almost any programming language you want to learn really shouldn't cost you that. You know what I mean? Besides the cost of the
exactly.
book, if you have the competence to study and the logic to follow it. The thing about programming is there's very little mathematics, and people think it's a lot of math. It's not true. Programming doesn't use a lot of mathematics at all. It's mostly logics and understanding syntax, and that's just part of it. But understanding actual methods and attributes of what you're going to apply the language to, that whatever project you're on, that's the most important thing. So if you look at what's the languages that are being most used right now? Python is really big. Java's always been big. JavaScript has always been big, especially for client side and some server side applications. But Ruby's really big now. But you can look at check out the net. There's a whole bunch of websites to talk about best programming languages for this given year or that given year, based on industry hiring. Salary.com if you want to get into programs, and just put in Java programmer and check out what the salaries are, and you can look at different regions of the country to see who's hiring where and what language is actually being used on the most projects nowadays. You'd be surprised. C++ and C is still being used widely.
Yeah.
Oh yeah. So even those very old languages, when I first got into programming as a kid, those languages are still being used. I've even worked somewhere where they had a custom COBOL program still running the legacy system. Man. So yeah, man. So you'd be surprised what actually is out there.
Man. So you get in, you get the job. What distinguishes sort of an ordinary tech employee from someone who rises the ladder and becomes a senior dev within, the first year or two?
You're not going to do that. I don't think you're going to rise to be a senior developer in just a year or two. There are guys out there that have been programming for years, and there are people who are just getting in the field too. But it really depends on what projects you're on. I always say this: if you get on a really cool project on some cutting edge stuff, man, especially all the cloud form stuff now, if you can do something like that and really learn on the project, that's going to help your career immensely. But day-to-day, maintenance and operation of systems is still very important. But getting on those projects really, really determines what you're going to do next. If you can get on a big implementation project, for instance, something off the ground and, work 2 or 3 life cycles, then you're looking at senior development, I would think. And that takes about 3 to 4 years.
Gotcha. So it's not like other fields. Like my last interview was sales, and Nick Rundlet, a friend of mine from the Praxis program, he ended up becoming like one of the managers of his company's sales within 3 months, just because he was outpacing all the other SDRs already.
And I think that's important too. You make that distinction. And sales is about how much revenue you can actually generate the company. If you're an electric personality and you can, magnetic rather, right? If you're a magnetic personality and you go out there and start meeting people and talking to people and forming relationships, or if you have a large base of people you already know that you can sell to, hey man, as long as you keep the revenue coming in, they'll make you vice president. But, right? But in technology, it's a little bit different because you do have to build up that life cycle knowledge of having actually run some projects first. I mean, you can learn the language, and any language. You can usually learn the language well enough to actually get a job in about 6 months to a year. But it's not just knowing the language, it's actually how it's applied. It's actually the troubleshooting aspect. It's a whole lot more that goes along to it than just learning a language, right? So once you've been placed in several different good situations where you're able to work your way out of it, you build up a good knowledge base and a good reputation, right, within the company that you're working or the environment which you're currently working, that helps a long way. If you're looking for that senior dev position, but it can definitely be done, within about 3 to 4 years. And think about the experience you're going to learn in those 3 to 4 years. You get a lot of experience.
Absolutely. What would you say the biggest misconception about being an engineer of any kind, hardware or software?
That it's glamorous somehow. I mean, it's boring, man. It's hours and hours of work. It's on-call duty a lot. So you have to, I mean, it's like anything else. If you are doing it for the money, that wears thin. You know what I'm saying? If you're doing it because it's something you really like to do, you love to do, I mean, and there's variations of that, right? But if it's something that you can actually put up with and you're cool doing it, do it. But don't let titles and the amount of money that you can make really steer your decision of how you're gonna take care of yourself and take care of your world. You have to have some interest in it because you got to be good at it. And that's important. You don't want to mess up any systems. You know what I'm saying? You don't want to create more work for your colleagues. Exactly. And you don't want to, kind of be on their coattails riding them either. And I've been on all sides of that, by the
way. Absolutely. Yeah. So if you do find yourself in that situation, I guess that kind of ties into my next question for you, which is like, obviously engineering is going to be mostly hard skills, but how important are soft skills in that context?
Absolutely important. I had a very good friend who told me one time that soft skills are probably more important than hard skills because you can find a whole lot of guys out there who are, systems engineers, systems administrators, software developers, analysts of all kinds. But can they fit in? Do they have that personality to actually talk to people and form dynamic teams and work with people one-on-one even? They're the kind of people you want to work with,
Yeah, absolutely.
Are they collegiate, are they collaborative? Companies really, really want that collaborative sort of hive mind thinking. And so to have those soft skills are vitally important, vitally important.
Absolutely. And so what, on a day-to-day basis, grand exceptions aside, what were your favorite and least favorite parts of some of the roles you've had? Like, I know you'd mentioned some of your experience prior. We've talked some about your experiences at like Google and Microsoft. Like, of all that stuff, there's bound to be some common aspects from job to job. So like, what are your favorite and least favorite parts?
I think whether it's Google, whether it's L3, whether it's Puget Sound, Packard, any of the places I've worked, a lot of it comes down to day-to-day, maintenance jobs. I mean, it's design, but it's one aspect of design. You know what I'm saying? You're working on one particular aspect of that. There's no person that works on everything because the systems are way too big. At L3, at PSC, we had 105 systems and 5 engineers. And then I worked at places pretty big, like Goodyear, you know what I mean? That had over 300 systems and about 25, 30 different engineers. So it just really depends on the project, but day-to-day stuff never changes. You know, coming into your, software checks and analysis, you've got all kinds of QA tests to do. And testing is vitally important. You have to have a lot of patience. So these are the things you're going to do on a day-to-day basis. A lot of sandboxing. Almost every idea I came up with, especially in my early part of my career, I was always told, sandbox your ideas, sandbox your ideas. And so you have to go set, an environment. A lot of times you had to create that environment. I had to actually implement it, design it, the whole 9 yards before I could actually test it. And that was especially the case for the TDMS systems, for SAP TDMS systems, right? Test Development Management Systems. Where you had to actually connect all of these systems together. You had to build the system, the central systems, and it was very, very complicated. And when you're on a project like that, then you're mired into the day-to-day technical realities of building that project and getting those deliverables done. Because that's the thing about any type of engineering or systems administration. There are always deliverables that are expected for you. You know what I mean? So it's like, if this has to be done in like 3 months, and it's usually, and a lot of guys know what I'm talking about out there, it's usually unrealistic.
My dad, when he was at I forget which aerospace firm he was at, but he always loved to tell the story of how on his chief foreman's desk, he had this metal placard, and engraved in it was, at some point you just have to shoot the engineer and move on with the project. That's right. Because if you leave it to them, they'll just be constantly making little refinements all to squeeze any bit of performance out of it, make it perfect.
Efficiency is the game, man, because efficiency is cost, right? Cost is price, and everything comes from that. But it can become very boring, tedious, repetitious. Because you're doing the same test over and over again, stress testing systems. So it can become, tedious and boring. So that's one of the parts about it that I least like. I love actually, designing the system from starting at the database and designing databases all the way through the operating systems up to the application itself. I love that. That's fun. That's engaging. I came to love doing homogeneous system refreshes. Those were complicated, time consuming, and always had to be done in 3 to 5 days. And so I really got into loving that. But what I didn't like was just day-to-day diagnostic system checks are boring.
Oh, absolutely.
Very boring.
And I guess that kind of takes us into the next question, which, as I'm sure you're aware, the average lifespan of an engineer at a company hovers just under 3 years. And so in tech, there's obviously an expectation of high turnover at pretty much whatever job you're at. And even the big dogs, your Googles, your Facebooks, they know this, which is where some of you get that rest invest effect. Because they don't want another engineer going on to another company's payroll.
Well, not even another company. A lot of engineers go to Google to have the bona fides to start their own company.
Exactly.
Right? So there's a lot of that too.
So I guess my question is, how do you best fight burnout when you're in that dynamic?
Wow, that's tough. I think, again, it has a lot to do with the project. Because if you can get on a project that's going to test you and push you, versus just doing day-to-day stuff that we talked about earlier. That's going to be a big difference. And if you have a project where you're just doing the menial task, especially if you're just starting out, they give you the menial stuff so that you won't mess things up too much.
Exactly.
A lot of manual reading, but you overcome that with time and experience. But how do you keep from burning out on it? It's you have to. For me, especially all the companies I've worked at, I noticed that different companies, same thing. You know what I'm saying? It was the same job. What's different are the people, and what matters, and what really helps that burnout are the people you work with. Number one, if you have a great team, great people around you, and you can contribute and you can learn, that's a great environment. Project or no project, right? The people are what make it, man. So if you don't want to burn out, I suggest you, work with really, really cool people who are, attuned to what's happening, who are intelligent. Training is also a very big thing, man, because that helps you to increase your, not just your confidence of working in a particular area of engineering or administration, but it also helps you later on, right? Because you get a skill, and that helps you to not burn out, because you're continually learning. Always forward motion and forward momentum will help you with the burnout. And teach yourself, man. Go read a lot. I read a lot, man.
Yeah.
You never stop studying and getting certifications. It just never stop. And some people think, well, that could burn me out. But in actuality, it actually can energize you too, because of the people you meet.
Yeah, absolutely.
A lot of the classes that you take and the people you meet and the connections you make and the networking.
Oh,
vitally important, man. Network.
The people I get to meet are one of my favorite parts of doing the whole startup thing. Absolutely. Exactly. Some of the stories you get to hear from people are just like, you can go through an awful flight, an awful way from the airport to the conference center, but then you meet that one person who's just like, they have this amazing story of some big historical moment that happened within your field. Like for me, it's music. And just getting them to hear them tell that story first person, no crappy documentary screen in front of you. It's just right from the horse's mouth. That makes it all worthwhile.
I agree.
And I guess that sort of ties into the next question, which is when and why to leave a company.
Wow.
If there's going to be, high turnover, you can expect you're going to have multiple jobs in an engineering career.
That's true.
So you need to know when it's time to start thinking about making a transition, if it's going to be sustainable for you.
Oh, can we stop here?
This is the last one, I promise.
Oh, it's already so late, man. You're standing in the cold.
Oh.
I blew it. I really have to stop it.
All right.
Can we stop here?
Yeah.
And we can go back and erase that part and start exactly where we left.
Alrighty. Back after a brief break to go pick up his son. Yeah. So we were on the question of when and why to leave a company.
Yeah, that's a deep question. I think just like joining a company, leaving a company as an individual, that's something that you have to judge for yourself. It's an individual decision. And many times we choose a company because of benefits, work environment, flexibility of schedule. Many times we leave companies for the exact same, opposite. No flexibility in schedule, no benefits aren't good enough, or we find something better. Everyone has to make that determination. But I think some of the major reasons we leave companies is because management will not change. Management is static. Companies are quote unquote cheap. They won't invest properly in research and development or in proper equipment and tools. I always live by the phrase tools, time, and training, right? If you got the tools, the time to learn them, use them, and grow with them, and the training in order to get to that point, that's a good company. If you don't have the tools, time, and training, a lot of people may end up leaving, And there's other things too. Diversity, is very important because then you have diversity of ideas and diversity of backgrounds. Companies that are pretty much monolithic, they tend not to grow as fast, or they don't grow at all.
Yeah.
Right? So it depends on the person too. Some people like that stability, man. They like to, stay at a big corporation and just ride it out for as long as possible. And there's other people who like to jump around and bounce so they can learn. And I was that person early in my career. I would jump from company to company so I can get on projects and learn as much as I could. So there's a lot of reasons why you leave.
Absolutely. I'd say that makes a lot of sense. Mm-hmm. And then last question, just for you.
Mm-hmm.
Go ahead and brag about the coolest thing you built in your career.
Oh, man, the coolest thing. There was a couple of things actually I was really proud of. The first was when I worked on the first was a TDMS project for Puget Sound Energy. That was a great opportunity. It was a new technology. It had not been really I don't think it was, no, it wasn't. It was never used at PSC. And so we actually did everything from proof of concept all the way through to actually building the system.
Ooh.
That was a lot of fun, man.
Yeah.
A lot of pain, a lot of pain, a lot of fun, a lot of hours.
Lots of cuss words late at night when parts broke.
Yeah, and a lot of late at night.
Yeah.
And early mornings. But the other project was the AI position I worked at when I was at Google. That was a really cool project.
Yeah.
Yeah, lots of really
It's kind of like right at the dawn of AI, wasn't it?
No, not really. It was already had been kicked around for a long time, but it was the first time we were actually going to apply high analytical appliance in-memory process, in-memory databases for the first time. And Hadoop, like, you know, Google developed Hadoop, and it just started coming on, and I got there. It was still a new technology when I started hitting on it. And that was big, you know, and that was a lot of fun. That was a lot of fun too. Again, hard, long nights, long days, man. But it taught me an incredible amount of information that I didn't know.
Oh, you know, bet. You're bound to pick something up when you're staring at a couple thousand lines of code a day.
13, 14 hours a day.
So keep throwing shit at the wall. It's going to stick eventually. That's right. All righty, man. Well, thank you so much for your time. Been a great one. And that's all, folks.